Okay, so let's see how this one goes for us. Now remember, for each of these, the key is we start out with the ratio of lengths. So for number 1 over here, what's our ratio of lengths? Good, it is 4 to 6. Now to make life a little bit easier on us, I'm going to reduce that to 2 to 3. Now we're finding volumes, so we need a ratio of volumes. How do you get that? Yeah, but we got to get the ratio out of the lengths first. You're right, the 128 is going to go on top over here eventually. What do we got to do to the 2/3? We got to cube it because it's volumes. There we go. 2 cubed is 8 and 3 cubed is 27. And yes, the 128 volume here does go with the smaller figures. That does go on top. So now we'll cross multiply and divide. 27 times 128 divided by 8, which is okay, that looks right. 432 square inches. Sorry, cubic inches. Okay. For the second one, we also have to start out with the ratio of lengths, which is going to be 10 to 6. Now again, I'm going to simplify it to 5/3. Okay, and we are looking now for ratio of areas. So you are correct. We have to square that. 5 squared is 25. 3 squared, 9. Now the 475 goes with the larger, so it's going to go on top. So that's going to be what? 19 times 9, 171. Does that look right? Nine times 475 divided by 25, 171. Perfect. Any questions? All right. And that is the biggest thing I catch people on. Now there's going to be a quiz that you might get today. Most people remember to do it on the quiz, but coming up in 2 weeks when we do it on a test, a lot of people forget. Because I would enjoy doing a quiz today. Okay, so you guys had this worksheet page from yesterday. There's a photocopy of a page out of a book. The top 6 were pretty straightforward. Those were just similar figures, direct ratios of lengths. I don't have any of those answers written down, but I'm looking at it here. Like for number 1, A looks like it should be like 1.5. Okay, any of those on the top 6 that you want me to go over? Number 6? Okay. Number 6 is an example of, even though it's a 3-dimensional object, it is still similar. Yes. So we have, well, let me try the second one here first. You have to stretch my artistic ability right away on a early morning, don't you? Okay, so. And dance. Okay, so truffle shuffle, no. So we've got this 9 to 16 ratio of lengths here. Those two sides correspond, we know they're equal. To find A corresponds with the 5. Now A goes with the 16, 5 on top. 16 times 5 is 80. Divided by 9 is 8.89. Still with the 9 to 16 ratio. For B, B corresponds to the 3. 16 times 3 is 48. Divided by 9 is 5.33. Still with the 9 to 16 ratio. C corresponds with the 4. If I put this over here, 4 would be that height. It's just drawn in the back section there. So 4 goes to C. 4 times 16 is 64. Divided by 9 is 7.11. Question. Okay. 7 through 16 is where I'm expecting the questions to come. Let's do like number 1. Number 1 is actually relatively a direct one. The floor plan of a building has a scale of 1/8 inch equals 1 foot. This is not a ratio, but it is a rate. 1/8 inch equals 1 foot. One room of the floor plan has an area of 20 square inches on the floor plan. What is the actual room area in square inches? Now, they want the actual room area in square inches, not square feet. Because of that, I'm going to change this ratio to 1/8 inch, or this rate to a ratio to 1/8 inch equals 12 inches. Still linear at this point. But that is a ratio of lengths. To get a ratio of areas, I do have to square that. 1/8 squared is 1/64. 12 squared is 144. On the floor plan, oops, yeah, I wrote 1/16, didn't I? That should be 1/64. 8 squared should be 64. So then the 20 square inches is on the floor plan, so that goes on top. So we're going to do 144 times 20 divided by 1/64. 184,320. You may have done 1/64 square inch equals 1 square foot. Cross multiply and divide to get square feet, and then multiplied it out to convert it back into square inches. That does work. Then did the 16. Okay. That'll work. That's the brute force way of doing it, but it does work. So that was 7. Number 8. A pipe at a sewage treatment plant, 75 millimeters in diameter. Now this is an example we kind of did in class yesterday. The pipe is 75 millimeters in diameter, discharges 2,000 liters in a given period of time. They want to increase the diameter of the pipe so that it'll discharge 3,000 liters. What am I increasing here? Well, I want to increase the volume, but I'm really only controlling the area, the cross-sectional area. So whatever this is here, I'm going to call that X. Now, a lot of people would go in and, well, okay, the radius here would be 37.5, find the area. Don't need to do that. If I increase the diameter from 75 to X, that's a ratio of lengths. If I square that, 75 squared, I believe, is 5,625. X squared, of course, is just X squared. That better equal my ratio of 2,000 to 3,000. Now, I am going to take a shortcut, divide those out to thousands. It's just a ratio of 2 to 3. So what I have there is that 5625 times 3 divided by 2. That's 28 x squared equals 28,126. Thank you. 5625 times 3. I didn't hit the times. That's what happened. Divided by 2. 8437.5. I need to square root that. You are correct. So I square root that to get x is 91.86. Oops, get back here. So the new diameter would be 91.86 millimeters to increase that flow to 3,000 liters. Any questions? Now, I'm not going to do every problem on the worksheet, but I'm going to kind of go down through here, just make sure we know what each of them corresponds to. A square bar of steel, 38 millimeters on a side, has a mass of 22 kilograms. What is the mass of another bar of steel? Here's the important part, with the same length, that is 19 millimeters on a side. So we've got this bar of steel. .38 millimeters on a side. Has some length that we do not know. Taking another bar of steel. 19 millimeters on a side. Same length. Have we altered the volume? No. To alter the volume, we would have had to alter the length as well. So all we have altered here is the cross-sectional area. 38 has become 19. That's our ratio of lengths. We will square that to get the ratio of areas. Now, before I square that, I'm going to make life a lot easier on myself. Reduce it to 2 to 1. Square that gives me a 4 to 1 ratio. And of course, the mass, 22 kilograms before, cross multiply and divide, it's going to be 5.5 kilograms now. Number 10 is kind of an interesting one because it goes backwards. It costs $982 to fence in a field, a circular field, with an area of 652 square feet. The only reason they said circular is circular guarantees that it has to be two circles are always similar to each other. They could have just said square, but if they had said squared, well, then it would have been a lot easier to find the side and work it that way. What will it cost to impose another circular field with 3 times the area? So that'd be 19,056 or 1,956 square feet of area. So what we have here, we have 982 compares to X. Why I put a 2 down there? Compares to X. But we're not comparing that to a length, we're comparing it to areas. So that has to be squared. 982 squared is 964, 324. X squared, of course, is X squared. And that's going to equal a 1:3 ratio. So I'm going to multiply, cross multiply and divide times 3 there. So 2, let's get out of there. 2, 892, 972. And of course, to find X, we need to square root. $1,700.87 it's going to cost. What do you think? Fun stuff? So, number 11. We're painting a spherical tank. Take 700 liters of paint to paint a tank with a radius of 20 meters. How much paint would it take to paint a tank with a radius of 35 meters? Well, what we have here is a ratio of the amount of paint to cover the tank is really a ratio of what property determines how much paint it takes. Is that a length? Is that an area? Or is that a volume? It's an area. Area determines the amount of paint it takes. The radius, is that a length, area, or volume? It's a length. So we do have a ratio of lengths, 20 to 35. I'm going to divide both by 5 to make my life a little easier. Give me 4 to 7. Then we'll square them, because we are going to an area. You give us 16 to 49. Then we'll put 700 liters there. 49 times 700 divided by 16. 2143.75 liters. What do you think? We having fun yet? So looking through are there any others that you guys want me to take a look at? 15, sheet metal. So we got a sphere with a 10 centimeter radius. Has a volume 4188.79 centimeters cubed and a surface area of 1256.64 centimeters squared. if everything is changed to a radius of 2 centimeters. Recalculate everything. Now, realistically, we know how to find, we've got the formula for area and volume. We could just take the radius and calculate, but that's no fun. We have a ratio of lengths. It's 10 to 2. For my sanity, reduced to 5 to 1. For volume, we're going to cube it. That's 125 to 1, right? The 4188.79 goes there. Times 1 divided by 125 is 33.51. So the volume of that smaller sphere is only 33.51 cubic centimeters. It's going to go back to this squared, so it'll be 25 to 1. So we will cross multiply and divide. 1256.64 times 1 divided by 25 is 50.27. Squaring or cubing. A spherical container with volume, give me just a second here. $7234.56. Cubic feet has a surface area of 1808.64 square feet. Find the volume of a spherical container with surface area of 452.16 square feet. I'm going to give you guys a second to try to figure that out. We'll talk about it. Okay, so what's our strategery here? Okay, so we've got the 1808.64 over 452.16. Now that is a ratio of areas. You have to square root those. Very good. Now I'm going to make life a little easier on you here. Before I square root them, both of those divide by 452.16. And what I'm doing is I'm turning it into a unit rate. I'm dividing by that bottom number. It comes out to be 4 to 1. If I do that, when I square root it, it comes out to be a 2 to 1. That would be the ratio of lengths. It's a little trick whenever you have a complex ratio like that, turn it into a unit rate, because then you're only working with one ugly number at least. You know, even if this top number came out to be a really ugly decimal, you're still only working with one ugly decimal, and you have the other one as 1. So square root of 1 is always 1. Now the ratio of volumes, I'm going to cube that, get an 8-to-1 ratio in my volumes. So I've got my 7234.56 times 1 divided by 8. Is 904.32. What you could have done is you could have cubed this and then square rooted it at the end. Yeah, that's probably round off here as well. If you tried to square root this directly, you get some ugly decimals that need to be rounded. Yep. Yeah.